I'm graphing this, and that 1 over 0 is undefined, plot those other points. We'll see if we can start to see a pattern. And granted, these are pretty hard to plot since they're fractions, which is why we won't be, once you see the pattern, we won't be plotting them anymore. 1 over is 1 up, 2 over is a half up, 3 over is a third up. I mean, pretty soon that gets pretty impossible to graph by hand. It's never going to touch the x-axis, is it? But is it ever going to cross the x-axis? No, because it's going to be a fourth, a fifth. It's going to just keep getting to be tinier and tinier fractions. So if it's never going to touch the x-axis, what's the x-axis? It's an asymptote. So the x-axis is an asymptote, and this thing just gets closer and closer to it as it extends outward. Okay, but what happens though between 0 and 1 here? I couldn't. There was no point for me to plot at 0. You think it goes? Because think about it. What if I did a fraction? What's 1 divided by a fraction? That's 2. 1/3 divided by 1 over 1/3 is going to be 3. Yeah, so it's going to go over half up 2. Whoops, can't see that. Up 2, then 1/3 over is up 3, 1/4 over is up 4. So what's the y-axis? The y-axis is also an asymptote. Most, not all, but most of the time, if you get an undefined value, it means there's a vertical asymptote there. If you get something divided by 0, that's usually where a vertical asymptote will be. There's a few special cases, but you can almost depend on that. So yeah, this baby just goes shooting up the asymptote as well. Okay, what was the only actually really useful point we plotted on that whole graph? 1, 1. So all you're going to do is plot asymptotes and then plot that bend point. That's it. Okay. Now, what have we not done yet? There's half of this graph missing. We haven't done the negatives. What happens on -1, -2, -3? Because if I was putting negative numbers in all of these, wouldn't all of these just be negative as well? So it's the exact same curve put where? Other side up here in the other. Yeah, it would be, it's -1, -1, so it's over here in the corner going down.
Can we just do it like that?
Yeah. You have to put the asymptotes on, plot 1, 1, and draw the curves.
On every one.
Not on every one of them, because I got to make a shift. But yes, they always have asymptotes. Always. They'll always have asymptotes through the origin. Okay. So 1 over x squared is almost the same graph, but one change. Because I mean, technically there's a little bit of difference in the points, but those fractions are so small you can hardly tell. And technically, yes, if I put 0 in there, it's still undefined. And if I put 1 in there, 1 over 1 squared is still 1. Technically, 2 in there, you square it, I get a fourth, so the fractions go down a little faster. But when you're talking teeny tiny fractions, that really doesn't impact our hand graphing very much. What changes is what happens if I put negatives on it. And I'm squaring them. The y-coordinates stay positive. The y-coordinates never change to negative.
You just flipped over.
So you're still going to have your asymptotes. You still have a point at 1, 1. And essentially this first quadrant curve just stays the same. The change is, where's the other curve at? Since it's got positive y-coordinates, I'm going to go left 1, up 1. So now I'm over here. And that's the only difference. It goes up. And yes, somebody knows what they've been named. I drew that one kind of crooked. It's not so great. Okay, I always called this the tree trunk until Zach Ridinghouse joined my class. Oh, was it Jordan that noticed it? Okay. I don't remember which one of them. So, yes.
Yeah, you know how it gets.
Yeah, tree trunk. So this is the roots of the tree going up.
Or the cheeks of the frog.
Yeah. Okay, and now the other one's a little harder to see. They call the other one a hallway. Can you see the hallway?
Yep.
Yeah.
It's like there's a hallway through this middle section. Like these are the walls of the corner, and there's the hallway cutting between them.
That was like someone going across the
So whatever you visually see in it, go for it. Okay. Now, how do you keep them straight? Which one's which? Which one's 1 over x versus 1 over x squared? Well, this is x squared. It has 2 cheeks. So that usually keeps it straight. Now, the good news is every other rule, we can shift these, we can make it move right, left, up, down. All the rules you know about shifting still apply. So we're going to go shift some here real quick.
Oh, we have to put it on the
So. So, let's put some pizzazz in this. Whoops, that doesn't work well. Go away. Suppose I said to you, what if I gave you 3 over x plus 4 plus 1? Okay, with all your vast knowledge of graphing, for as many times as we've done this, what's the plus 1 do to every single graph? Add it on the end. There's a difference between added on the end or replacing x with a quantity. So which one's up and down? The plus 1 is up and down. When you go up and down, you don't change the sign. So this is up 1. That's going to go left 4. Okay, in this instance, that's the most important point you actually plot because that's your new origin. So if we go left 4 and up 1, what has to go through that point now? That's where your asymptotes go. Wherever you shift to, that's where you throw your asymptotes down. No, you don't have to do the t-table at all. I told you, these are the easiest graphs you ever get to draw. Okay. So now, what other number, though, is up there that we haven't dealt with? The 3. Actually, I should ask you this. Which graph is this, the hallway or the vet track? Why do you know it's the hallway? It's not squared. If it's squared, the whole bottom will be squared.
So the one, do you usually the 4 and 4, or do you make go back to a 16?
No, usually the 4 is 4. Yeah, I'll do a squared one in a second. Okay, you remember what was the only coordinate you were going to plot? You're going to plot 1, 1. Okay, that 3 took this entire thing times 3.
There's always going to be a 1.
Yeah, well, it's going to change here in a second. If that's a 3 on top, you remember when we did when you did parabolas and you had a 2 out front, you did your 1, 1, 2, 4, 3, 9. What did you do with the 2? You multiplied all the y coordinates times 2. So in this case, that's like multiplying it by 3. So you multiply the y coordinate times 3. Yes, it makes that a 3. So instead of plotting 1, 1, you plot 1, 3. That's the only change to it.
So this makes the corners of your hallway higher.
Yes, makes you have a wider hallway. So 1 over 3 up. So then where do I go with the point in the other quadrant? It'll be 1 over 3 down. That will be your point. Okay, when you hit that point, that's when you break toward the other asymptote. That's where it starts to curve out toward the other asymptote. So, like the one I did before, whoops, where'd you go, dude? Okay, this one was really, really, really close to the origin, our point there. And we had very little space between the origin and our curves. This is going to have a lot more space. So now when I break this, I'm going to come down my vertical asymptote. When I hit that point, that's when I start heading for the other side. Oops, I missed there a little bit. Try that again, but I wasn't watching where my asymptote was. But you'll have more space in there. When I come up this asymptote, then I break toward the other asymptote. So you got a much wider hallway. That's all that changes. Okay, so prove to me you're brilliant now. All right. This time, I want to graph y equals negative what on top?
2.
2? Okay. Negative 2. My quantity is x minus 3. Okay. Quantity squared.
Butt crack.
Plus 2. Okay. Why is it a butt crack? Okay, it's x squared. It's going to have 2 cheeks. You're going to really love the way this one turns out, too. You're going to... Okay, so where does it shift? Up to... This is same side. When it's inside, it's opposite sign, so it's right 3 up 2. So right 3 up 2. Draw what immediately? Asymptotes. And then, okay, this time it's got a negative on it. What's a negative on front like that do to it? It flips you up and down or sideways? Yeah. In this case, a negative out front, in this case on top, negative is upside down. So if your normal curves were up top side by side, where are they now? Now they're on the bottom side by side. So when you plot, in this case, will I plot 1, 1? It's 1, negative 2 that I'm plotting. Because that's a negative, so I'm going to go 1 over and 2 down on both sides. And then I'm just going to draw my curves in. It always changes the y coordinate. The x coordinate will always be 1. X is always 1. That was bad. I look at it as bent over.
Okay,
I agree.
That's true.
Hell no, or when they talk about plumber's butt, you know, you bend over, your plumber bends over in the gap, and
Oh my.
I never have trouble with getting people to remember these graphs. That's just not a problem, and you have to plot one something. You know, there's not a lot of plotting here. Okay, I almost did what I was going to tell you not to. Whatever you do, don't do this. Don't come along and then get at the end just kind of fling your pencil. Yeah, it can't go away from the asymptote. So make sure you keep following the asymptote.